Well, hello, this is Nitin Dahad and Pablo Valerio at the HiPEAC 2026 conference in Kraków, Poland. And we're at the end, almost at the end of day one, where we had a keynote from AMD, Michaela Blott. And then we've had some very interesting conversations with people, and I attended some of the Technology Meets Society presentations. And Pablo, what did you meet? You attended some sessions today as well, didn't you? Yes.
Well, I was mostly, apart from attending the keynote this morning with Michaela Blott, I was attending several sessions for quantum computing, European quantum computing, the Euro HPC, initiatives, and Quantum Europe from the European Commission.
So yes, I mean, what anything interesting from those, from the quantum?
Well, it's
obviously you had the big news today.
Well, the big news today is, quantum computing has been, in the past few months, has been jumping in basically everywhere, especially in the financial community. There are several companies that they are getting really, really high valuations right now. I mean, in certain cases, companies like, for example, D-Wave jumped like 300% in the last 6 months, and then companies, Rigetti, even IBM is actually going higher. And today the big news is that IonQ bought Skywater, exactly, about the Skywater.
So was it 1.8 billion valuation?
Something like that, exactly, yeah. They're paying that, exactly, for the company. So that means that there is a lot of money flowing into quantum computing, which is still a technology that is considered like deep, tech, not really ready for going into the market like with big applications. But even Europe is doing a lot right now, putting together, for example, supercomputers with quantum computers, working together, just trying to find, the real applications for the technology.
But in that Skywater press release, I remember reading very briefly. I mean, we've been here today, and the story will be in EE Times. But I think that by 2028, testing 20,000 qubits or something like that. Yeah, pretty impressive.
Yes, and actually, what happens right now is that, especially IBM, which is a company that has been doing quantum computing for a long time, they're really scaling their technology very, very fast. And the only thing is, like when we're talking about, for example, academic or let's say pure research, they don't have the infrastructure for doing the same thing.
Let's come to here. What did you learn today from the sessions on the quantum?
Well, one of the things is that there is a lot of investment in Europe from the European Commission and national investment as well. So there are different clusters in different countries, and now they are basically putting together like supercomputers with quantum computers, just finding real applications for the technology. So here in Poland, they already have quantum computers not only sitting next to supercomputers, but also connecting different nodes, for even doing some kind of parallel processing with quantum computing, which is something really, really amazing.
Okay. I mean, I want to go to the Michaela Blott keynote. And one of the messages I got from there is, her title was Full Automation of the Scientific Discovery Process. And when you listen to NVIDIA, listen to AMD, it's pretty much the AI is good for the scientific discovery process. But what I felt like with Michaela is sometimes, with the NVIDIA talks, you hear more about the horsepower, the GPUs, and more GPUs, whereas she's talking about doing, we're throwing too much at AI models, and we need to be a bit less lazy, and talked about the challenges around algorithmic, around technology scaling, and around efficiency. What were your thoughts?
Well, when she was talking, actually doing more, let's say, optimization, especially in algorithms and things like that. And one of the things that she mentioned is there was something like $300 billion investment in AI, in actually, harboring AI last year or something like that. And it's only achieving 80% use of the GPUs. So she said something like, okay, well, we have $100 billion that are wasted. Because we are not basically optimizing the application. And I thought it was more or less the same thing that happened like 20 years ago, when basically, because of the performance of the new CPUs, software architects, they got lazy and they didn't optimize their code because they were getting a lot of performance. So in a way, with the amount of money, with the amount of energy, with the amount of resources that AI is using, it's very, very important that we change a little bit the mentality and getting more efficient.
Well, she talked about the efficiency challenge. Even with rapid base case growth in AI power, the shortage could be around 100 gigawatts by 2035, and that's kind of huge. Yeah. So she said, we need to address efficiency at all levels, and she talked about algorithmic efficiency, compute efficiency, and efficient inference. And sort of move towards silicon diversity, 3D architectures, staying on chip, and that kind of stuff. So I thought, it was quite effective talk amongst a research community. And I think it was quite useful to understand that.
Yeah, absolutely. And one of the interesting things is that she mentioned this term RAMaggedon, talking about the memory, the memory shortages, and the jump in prices in memory, which is going to make all these new data centers in AI much more expensive, and it's also and we wrote about that on EE Times, several articles, that what's happening as well is affecting consumer products because of the price of memory is going up. So
exactly. Yeah. I mean, I think AMD. The thing I got from there is, there's a lot of realism in some of the talks from AMD, whereas I don't see that much from NVIDIA. But anyway, that's kind of maybe I don't attend the right talks.
Well, the thing today is that both NVIDIA and AMD and others right now, they sold everything they can produce.
Yeah.
So there is absolutely no need for competing in terms of just trying to get orders, because that's true. So the important thing for them is just to be more really able to optimize their performance. So they're investing, and I think AMD is probably, you're right, and I don't have any numbers, but I think AMD, the mentality is to invest a lot more in efficiency.
Correct. Yeah, and talking about efficiency and automated, I was with a company called Polyminch over there, which is a startup from the Indian Institute of Science. And there's a video that you'll see in the feed today. But it's quite interesting. They're doing automatic compilers to translate the high-level languages, the PyTorch and everything, to all the GPU, AMD, NVIDIA, TensorTorrent, and all the different CPUs, GPUs.
Oh, right.
And it's sort of automatic compilers. I had a long conversation with somebody, I'm not going to mention his name, but today about how the industry is wasting so much time on hand tweaking code for each CPU, GPU, or instead AI accelerator chip. And I think that's what they're trying to address. So it was quite interesting.
Well, interesting. Yeah. And actually on the quantum computing part, one of the interesting talks was about doing the same thing, like writing code and doing compilers for the different types of quantum computers, because even in quantum computers today, we have analog quantum computer, we have digital quantum computers, we have trapped ion quantum computers, all these different things, and the gates of these are different. So there is a lot of software optimization and research going on.
The last thing I wanted to talk about is back to my Technology Meets Society. I think I was quite fascinated by it for all kinds of reasons, but again, what's the reality of AI? And one of the professors, and she talked about the critical risks of the dark side of AI, and one of the risks was the death of visible ignorance. So, for example, you could tell in the past when someone was visibly incompetent, but now simulated competence becomes indistinguishable from real competence. And I think that's kind of a message was like, let's use AI for what it is, but let's make sure that we're not losing grasp of the competence and the reality and things that don't make us lazy.
Yeah, well, it is true, and actually there is a lot of talk about that right now, and especially even with children and teenagers that are now using AI. And even at the university, it's funny because I do some work with one of the universities in Barcelona, and one of the professors was telling me, I don't have any problem that they use AI to basically produce some stuff, but if they want better grades, they have to tell me in person, aloud, and I can ask questions, and so they know what they're talking about. So.
Yeah, I mean, it's going to be fun. But Pablo, thank you very much.
Thank you.
Hopefully we can do something for the next couple of days, but for now, we're signing off. This is Nitin Dahad,
and this is Pablo Valerio.
And we'll see you again soon.
Okay.